All right, so we were looking at some solving equations. So we're going to be solving to the nearest tenth of a degree from 0 to 360. So the first thing I want to do on my calculator is double check that I'm in degrees. And I wasn't, so that would have been a problem. Okay, so double check that I'm in degrees. And we already did these first two, so I'm going to go head down to the third one. So first thing I'm going to do is isolate cosine. So I'll subtract 5 on both sides. I get 3 cosine theta is equal to 1. Divide by 3. So cosine theta is 1/3. Now I'm going to do an inverse cosine, or an arc cosine, and what that does is it solves for the angle. Now, cosine theta equaling 1/3, that happens, cosine the x value being a positive in quadrant 1, and it also happens in quadrant 4 because quadrant 4 has positive x's and negative y's. So I'm going to do my inverse cosine of 1/3, and this is going to give me one of those two answers. So let's look. 70.5. That's giving me my quadrant 1 angle. Okay. I still need to find what the angle in quadrant 4 would also be. So I'm going to draw a quadrant 4 angle that has a reference angle of 70.5. But this piece right here that goes around the other way, that's the angle we're looking for. To find that one, we're going to do 360 minus 70.5. So I'll take out my calculator. 360 minus 70.5, 289.5. Now this second angle that I found in red is where the most common mistake on this section is. People find the first angle no problem, but then the second angle they get tripped up on. So if we wanted to at the end, we can double check by doing 3 cosine of my angle 70.5 plus 5 and see how close we get to 6. We're not going to get exactly 6 because we rounded it to the tenths, but 6.0014. It's fairly close. This is another way we can check that we found the second angle correctly, that we didn't make any sign errors or calculation errors. And you can see it's also pretty close to 6. So on the next one, we're going to do the same step. We're going to isolate tangent. So I'll add 4 to both sides. I'll divide by 5. We get tangent theta is 6/5. We don't have to worry about that this value is larger than 1 because I have tangent here. And tangents, the domain for inverse tangent or arctangent is all real numbers, or the range on the original tangent function is all real numbers. So my tangent's going to be positive in quadrant 1 because it's a positive divided by a positive. The other spot where tangent's going to be positive is in quadrant 3 because it's a negative y value divided by a negative x value, which will also give me a positive. So we're going to want an angle in quadrant 1 and we're going to want an angle in quadrant 3. So let's see what angle this first one gives me. So inverse tangent, and oops, I have a regular tangent. We want inverse tangent of 6/5, and that will give me 50.2. When I go to find the other angle, we're going to have a reference angle of 50.2 in quadrant 3, and I want this 180 and then another 50.2 also. So this one, it's going to be 180 plus 50.2, or 230.2. Again, that second angle is the trickiest part on this. It's where most mistakes happen. Okay. Again, I can double check my answer. So we say 5 tangent of 50.2 minus 4 should come out pretty close to 2. Yeah, pretty close to 2. And then 5 tangent of 230.2 and minus 4. Okay. Now on the next type of problem, still same style problem, but instead we want to the nearest hundredth of a radian from 0 to 2 pi. So we have to double check our calculator and change the mode. So we're going to change it over to from degrees to radians because I want it in radians. So the beginning part is going to seem very similar. We're going to subtract the 5. We're going to isolate that trig ratio. And then I'm going to divide by 2. And we get cosine of x is equal to 1. Well, that actually is a unit circle value. And it is one of the quadrantal angles. It's along the axes. So this is x is equal to 0 radians. We don't want to say 2 pi radians because 0, here you can see 0 is included in my interval and 2 pi is not. That's my only answer. It's the only time on the unit circle. Well, it's 0 and it's 2 pi, but they do not want the coterminal one on this. All right. Next one, secant of x is equal to 4. So I'm going to rewrite that as 1 over cosine, because that's what secant is. Then I'm going to multiply both sides by cosine x. 1 is equal to 4 cosine x. So cosine x is 1/4. I could have also gotten this from the original by just writing the reciprocal and jumping straight to that, but I wanted to make sure people saw where that's coming from. So 1/4 is not on the unit circle, so I'm going to need to use my calculator. So I'll do an inverse cosine or an arc cosine of 1/4 to find the angle. Inverse trig ratios find angles. So now I'm going to do secant cos 1/4. And it's going to give me a decimal, 1.32. We're rounding to the hundredth. That's 2 numbers after the decimal point. 1.32 radians. You don't have to write radians, but I tend to. Now that's the first angle. But as we said before, cosine's positive in 2 different quadrants. So there's one in quadrant 1 and one in quadrant 4. We just found our quadrant 1 angle. Now we need to find the quadrant 4 angle. I'm going to set it up by drawing my picture. I have an angle right here of 1.32. And then I have this piece, which is one full rotation except for the 1.32. Now, only difference here is this full rotation now is no longer 360 degrees. It's 2 pi radians. So we'll do 2 pi minus that 1.32. So take my calculator, 2 pi minus 1.32 and get 4.96. So the other angle here is 4.96. Yeah, 96. Because this is rounded and it's rounded and the 1.32 is rounded, you're also going to see that you won't have an exact answer on these as well. So 1 divided by cosine of 1.32 is 4.02. It's pretty close to 4. It's a little further off than our degrees were. 1 divided by cosine of 4.96. And again, close to 4, but not exactly it because of all the rounding. And that one was double rounded, which is why it was a little further away than the last. Okay. Next ones. So we want nearest tenth of a degree for all angles. Now this is different than what we had before. Before we had from 0 to 360. So we wanted in just one revolution. For all angles means I want expressions for all the coterminal angles. So that means I'm going to see some plus 360n kind of action going on in it. So we're going to start by adding 3 on both sides. 5 cosine theta is equal to 4. Divide by 5. Cosine theta is 4/5. And then I'm going to do an inverse cos of 4/5 will tell me theta. Again, inverse cosine or arc cosine helps me find angles. Inverse cosine of 4/5. And I have an angle of, I think it was 0.64. Yes, it was. 0.64. Okay. I'm in radians, not degrees. Hold on, try again. See? Everybody makes mistakes sometimes. Try again. 36.9 degrees. That makes more sense. 36.9 degrees. Now, that would be So that would be within one revolution, but I'm going to write plus 360n to describe all of the angles that are coterminal to it. Now that's my quadrant 1. Since cosine is a positive, that's going to happen in quadrant 1 and quadrant 4. My quadrant 4 angle has a reference angle of 36.9. I want the angle that goes on the other side. Whoop, that was not the red. There we go. And to find that, I'll do 360 minus 36.9. And we get theta is 323. 323.1 degrees plus 360n. Okay, so we want to make sure that, and these n are where n is representing an integer. Okay, so let's see. This one we're going to subtract 7, so we get 8 tangent theta is equal to negative 12. Divide by 8. Tangent theta is negative 12/8 or 3/2. Now, tangent equaling a negative is going to happen in two quadrants. It's going to happen in quadrant 2 and quadrant 4. Okay, because those are the ones where it's not positive. Okay, so I'll do arctan of negative 3/2 is equal to theta. This is going to give me my theta, arctan of negative 3/2. Now that tells me negative 56.3. Now it told me a negative angle because it found quadrant 4 by rotating clockwise instead of going all the way around. If I wanted an angle between 0 and 360, I would need to find the positive coterminal. I don't need to do that in this problem because it's okay for it to be negative. But let's say I needed it because of the directions. I would do, this is negative 56.3, so I'm going to do 360 minus that 56.3, 303.7. Okay. Now, again, this would have been really important if my directions said between 0 and 360. All right, so here we're going to say plus 360n. Oh, that got a little, oh, sorry. Plus 360n. For the directions on these are interchangeable. Okay, now I need the quadrant 2 angle. So the quadrant 2 angle is going to be over here. I've got a 56.3 there, and I'm less than 180 by 56.3. So I'm going to do 180 minus the 56.3. So theta, the second angle that I need to find, 180 minus 56.3 gives me 123.7 plus 360n. So again, these problems have the plus 360n because the direction said for all angles instead of on an interval. Last two. So solve to the nearest hundredth of a radian. So I want to be in radians. And we're going to have for all angles. Now, for all angles, we're still going to have that plus, but instead of having 360n, we're going to have plus 2 pi n. Oh, I should have written where n is an integer. Sorry. So we're going to have plus 2 pi n on it. So I'm going to start by subtracting 3. 4 sine theta is equal to negative 2. Divide by 4. Sine theta is equal to negative 1/2. Now that's a unit circle value. So I'm going to do this one as unit circle values and give exact answers instead of using my calculator. Okay. 1/2 are part of the over 6 squad. And since sine is negative, I want to be in quadrant 3 and quadrant 4. So that's telling me that theta should be 7 pi over 6 and 11 pi over 6. Since these are looking for all angles, I'm going to write plus 2 pi n at the end to describe all of the coterminal angles, where n is an integer. Okay. Last but not least, ooh, this one's a little spicy. 12 secant theta plus 17 is equal to negative 5. All right, so this is like 12 over cosine theta plus 17 is equal to negative 5. So I'm going to subtract the 17. 12 over cosine theta is equal to negative 22. Multiply both sides by cosine theta. 12 is equal to negative 2 cosine theta. Divide by negative 22. Cosine theta is negative 6/11. Definitely not a unit circle value, so I'm going to need my calculator. I'm going to do an inverse cosine or arc cosine to find the angle. I want to double check my calculator because this problem was in radians. See, I would have had a problem. Double check my calculator. Now I'm going to do an inverse cosine of negative 6/11. Now the thing about this problem, 2.147, so 2.15. Theta is 2.15 plus 2 pi n. Okay. Cosine being negative, that happens in quadrant 2 and in quadrant 3. So the angle that I found, 2.15, it's a little harder to visualize than the other ones, but that's like around here-ish, 2.15. So there's my quadrant 2 angle. Quadrant 3 angle, it's going to have like this. This is going to be 2.15. And then the piece that I want to find is over here. So you can see how this red arc and this black arc together make a whole circle. That's why I'm going to do 2 pi minus 2.15 here to find the other angle. So 2 pi minus 2.15, and that comes out as 4.13. 4.13 plus 2 pi n, where n is an integer. On any one of these, I know I didn't check them on the past couple, and that's okay, but on any one of these, if I wasn't sure, I could also check that. So this concludes our video on finishing equations.